For section 1, we're going to graph the following inequalities. But first, let's go ahead and review an open circle and a closed circle. So if the circle is open on the graph, we are going to be looking at the inequality symbols greater than, less than, or not equal to. If you have a closed circle, it's because you have the inequality symbols greater than or equal to, less than or equal to, or equal to. All right, so our first inequality is x is less than or equal to 23. If I look at the symbol, I know that I'm going to have a closed circle on 23. Now it says x is less than or equal to 23. So I know that my x, or my solutions, are going to be less than. And you also notice the alligator mouth is not open to the x. So I know it's the smaller numbers. So I'm going to go to the left because all of those numbers are less than 23. 22 is less than 23. 21 is less than 23, and 20 is less than 23. But we can also have it equal to 23. That is why our circle is closed. Next we have x is greater than 3 1/3. All right, so this is going to be an open circle on 3 1/3. Now, this is going to be in between 3 and 4. Now, if I go to 3 and 4 and I cut this into thirds, so 1, 2, 3, I now have 3 pieces in between 3 and 4, and I only want 1/3. So I'm going to be right here and have an open circle. Well, I know that x is being eaten by the alligator and it's the greater than symbol, so I know that I need to go to the right because all of those are greater than 3 1/3. All right, next we have x is less than 5 2/3. So we need to go in between 5 and 6, and once again, we're cutting this into thirds to 3 pieces. Well, this one time we have 5 2/3, so I need to have 1, 2 of the 3 pieces, and this is going to be an open circle because it's a less than inequality symbol. So I'm going to make an open circle on 5 2/3. And we notice that x is less than, and the alligator mouth is not open to the x, so that means it's smaller. So we're going to go to the left because all of those numbers, those solutions, are smaller than 5 2/3. All right, last we have x is not equal to 16. Well, we notice that not equal is an open circle because it's not going to be equal to 16. So what solutions are not 16? Well, we know that all the numbers to the right are not 16 and all the numbers to the left are not 16. So our arrows are going to go both ways. For our next 2 problems, we are going to write the inequality that is represented in the number lines below. Okay, so for our first graph, I have all my solutions going to the left, and then I have the number 54. So I'm going to write x, and I'm going to write 54. Okay. Well, I notice that all of my solutions are going to the left, so I know that x is going to be less than 54. And since the circle is open, we know that it's not going to be equal to 54, so your solutions can only be less than 54. So x is less than 54. All right, next, I notice that all of my solutions are going to the right. So I notice that they're actually going to be larger this time. So I'm going to write x, and I'm going to write 13. And I know that x is larger or greater than 13, but since the circle is closed, it could also be equal to 13. So x is greater than or equal to 13. For section 2, we're going to solve each of the following by isolating the variable. So first, I'm going to draw my balance on the first problem, and I want to isolate the variable t. Well, if you notice, next to t, you have 27 39 hundredths, and I see that it's positive, so I'm going to do the inverse by subtracting. So minus 27 and 39 hundredths. And I'm going to do the exact same thing to the other side. Minus 27 and 39 hundredths. And I'm going to go ahead and rewrite this problem a little bit larger so you can see me working it out. So I have 62 and 52 hundredths minus 27 and 39 hundredths. And remember, when you add and subtract decimals, you always have to line the decimals up. All right, so let's go ahead and subtract. 2 take away 9. We're going to have to borrow. 5 becomes a 4. We're going to add 10 to 2 and making that 12. 12 take away 9 is 3. 4 take away 3 is 1. Bring the decimal down. We're going to have to borrow again. 6 becomes a 5. 2 becomes a 12. 12 take away 7 is 5. 5 take away 2 is 3. So I know that 35 and 13 hundredths is equal to t. All right, we're going to do the same thing to the next problem. I'm going to draw my balance. I want to isolate the variable f. So instead of minus 19, I'm going to do the inverse operation, so plus 19. I'm going to do that on both sides, plus 19. All right, so 9 plus 1 is 10. 1 plus 3 is 4, plus another one is 5. 50 equals f. All right, so for the next one, I'm going to draw my balance again. So I'm going to look at the side of the equation that has the variable, and I see t, and I want to isolate that. And the operation that I'm noticing is division. So we have t divided by 7. So the inverse would be to multiply. So we're going to do times 7 times 7. So these are going to cancel out, leaving your t by itself. And then let's multiply 13 times 7. So we know that 7 times 3 is 21. And 7 times 1 is 7. Plus 2 is 9. So 91 equals t. All right, so once again, we need to draw our balance. And I see that we want to get z alone. That's the variable we want to isolate here. And next to it is minus 4 and 2/5. So we're going to do the inverse operation. We're going to add 4 and 2/5. Do the same to the other side. Add 4 and 2/5. All right, so when you add fractions, remember adding and subtracting fractions, you have to have a common denominator. So I'm going to go ahead and do that. And I notice my common denominator here is going to be 10. So for 8 and 3/10, I don't need to do anything because I already have 10 as the denominator. Okay, so I'm just going to look at 2/5. Well, I know 5 times 2 is 10, so I do the same thing to the top. 2 times 2 is 4. And don't forget about the whole number, 4. So I'm going to have plus 4 and 4/10. All right, so 4 plus 3 is 7. The denominator stays the same, and then we're going to add the whole numbers. 8 plus 4 is 12. I can't simplify that, so I know that z equals 12 and 7/10. All right, I'm going to draw my balance again. I want to isolate y. I notice that that operation is multiplication, so I'm going to divide 6 because that's the inverse operation. I'm going to do it to both sides. So y equals 42 divided by 6 is 7, so y equals 7. All right, for our last one in this section, I'm going to draw my balance. And b is the variable that we want to isolate, but we notice that we have divided by 11, so we need to do the inverse, multiply by 11 on both sides. So those are going to cancel out, leaving b alone. All right, and so now we need to do 6 3/10 times 11. Well, I'm going to write this problem without the decimal for right now. So 63 times 11. So 1 times 3 is 3. 1 times 6 is 6. Add a placeholder. 1 times 3 is 3. 1 times 6 is 6. We're going to add these up. 3 plus 0 is 3. 6 plus 3 is 9. And 6. All right, so we got to go back to our problem that we started with right here. We noticed that there's one number behind the decimal, and then 11 doesn't have a decimal, so there's only going to be one number behind the decimal in my answer. So I'm going to put my decimal right here because there's only one number behind the decimal. So B is equal to 69 3/10. All right, for section 3, we're going to solve each of the inequalities for the variable and graph the solution on a number line. So this is just like what we did in section 2, but now we're going to be looking at an inequality. So the symbol is just going to look a little different, but we're going to do the exact same thing. All right, so 8 times x is greater than 28. So I'm going to draw my balance. I want to isolate the variable. Well, I see that 8 times x, so I see multiplication. I want to do the inverse, so I'm going to divide by 8. I'm going to divide by 8. So I have x by itself. I'm going to bring the inequality down. Don't write an equal sign because we're not looking at an equation. I'm looking at an inequality. So x is greater than, and we have 28 divided by 8. So 8 does not go into 2, but it goes into 28 3 times. 3 times 8 is 24. We're going to subtract. 8 minus 4 is 4. 2 minus 2 is 0. We're going to add a decimal. Bring the decimal up. And then we're going to add a 0. And bring the 0 down. We know that 8 goes into 45 times. 5 times 8 is 40. Subtracting is 0. So I know that x is greater than 3.5. All right, so we also have to graph the solution on a number line. So I'm going to draw a number line. And I'm going to write, let's do 2, 3, 4, 5, 6. Now we notice this is going to be an open circle on 3.5. And 3.5 is right in the middle of 3 and 4. So I'm going to write my open circle right in the middle. And I notice that the alligator mouth is open to the x, meaning all of my solutions are going to be greater than 3.5. So I'm going to go to the right because all of those numbers are greater than 3.5. All right, for our next inequality, I'm going to draw my balance. I want to isolate the variable x, so instead of subtracting 5 2/10, I'm going to do the inverse, so plus 5 2/10, plus 5 2/10. I'm going to rewrite this because it's kind of small, and I also need to make sure that my decimals are lined up because I'm going to be adding. So I have 3 6/10 plus 5 2/10. So 6 plus 2 is 8. Bring my decimal straight down. 5 plus 3 is 8. So I know that x is less than or equal to 8 8/10. Okay, now we need to go ahead and graph this on a number line. So I'm going to draw my number line. And I'm going to write 7, 8, 9, 10, 11. Okay, so we know that this is going to be a closed circle because it could also be equal to. And I have 8 8/10. I know that's going to be between 8 and 9. And since I have 8 8/10, I almost have all of the 10 pieces. So that's going to be closer to 9. So I'm going to draw my closed circle a little bit closer to the 9. And then let's look at our x. It is less than, and it's also not being eaten by the alligator mouth, so I know that it's smaller. So I need to draw my line and my arrow to the left because all of my solutions are less than or equal to 8 8/10. All right, and our last one. We're going to draw our balance, and I want to isolate the variable. I notice there's division, so I'm going to do the inverse, so times 4 times 4. So x is less than 20. All right, so we're going to put that on a number line. So I'm going to write 18, 19, 20, 21, 22. All right, so we know that this is going to be an open circle on 20 because it's not going to be equal to 20. And then our x is less than 20, and the alligator mouth is not open to the x, so I know it's smaller. So I'm going to draw my arrow to the left because 19, 18, 17, 16, 15, and so on are all going to be less than 20. For section 4, we are going to figure out what are some solutions to these inequalities. So we're going to give at least 2 solutions for each of the following problems. So the first inequality is x is less than 6. And you know it's less than because the alligator mouth is not open to the x. So I'm going to write 2 solutions for x. So I know that x could equal 5 because 5 is less than 6. And I know x could equal 2 because 2 is less than 6. All right, for the next one we have x is greater than or equal to 7.5. So I could say that x is equal to 7.5 because I know that 7.5 is equal to 7.5. And then I could also say x is equal to 9 because I know that 9 is greater than 7.5. All right, and for the last one, x is greater than 8 25/100. And if you notice, the x is being eaten by the alligator mouth, so you know it's larger. I'm going to say x is equal to 9, because I know that 9 is greater than 8 25/100. And x is equal to 12. 12 is also greater than 8 25/100. For section 5, we're going to figure out if this is a solution. So is x equal to 28 a solution to the equation x plus 42 equals 70? So we're just trying to decide, in this equation, is x going to be equal to 28, yes or no? So I'm going to go ahead and solve this equation. So x plus 42 equals 70. So I'm going to isolate the variable. So first draw my balance, and I'm going to isolate by subtracting 42 on both sides. So x is equal to, so I'm going to need to borrow. 7 becomes a 6, 0 becomes a 10. 10 take away 2 is 8. 6 take away 4 is 2. So x equals 28. So that is, yes, going to be a solution because x is 28, and when I solved, x is 28. All right, so next we have, is t equal to 7 a solution to the equation 64 equals 9 times t? All right, so I'm going to show you another way that you could look at this problem. Instead of solving the equation, I could go ahead and substitute 7 in place of t. So I could say 64 equals 9 times, instead of putting t, I'm going to say 7. 9 times 7. Well, 9 times 7 is going to give us 63. Well, is 64 equal to 63? No. So this is not going to be a solution. Right? So the next one is x equal to 140 a solution to the equation 26 equals x divided by 5? So we're trying to figure out, is x going to be 140 in this equation? All right? So I'll show you the first strategy from the first problem. So I'm going to actually solve it. So 26 equals x divided by 5. And draw my balance. Inverse operation here would be to multiply by 5 on both sides. So x is now alone. So we're going to do 26 times 5. So 5 times 6 is 30. 5 times 2 is 10, plus 3 is 13. So 130 equals x. Well, that is not the same thing, so no, this is not going to be a solution. All right, and then last, is k equals 49 a solution to the equation 88 minus k equals 39? So let's look at the second strategy that I talked about. So I'm just going to go ahead and substitute k with 49. So I'm going to do 88 minus 49 equals 39. So let's go ahead and do that. So 88 minus 49. All right, so we're going to have to borrow here. So 8 becomes a 7, and then 8 becomes 18, and then 18 take away 9 is going to give us 9, and 7 take away 4 is going to give us 3. So we know that 39 equals 39, and that is true. So yes, this is a solution. All right, for the last part of your test review, we are going to write an equation or an inequality for each of the following word problems. Solve each equation for the variable. So some of these problems you will solve, and some of them you will just have to write it out. So for the first problem, we see that the minimum age for voting in the United States is 18 years old, and we're going to let A represent the voter's age. Okay, so if you have to be a minimum of 18 years old to vote, so the very smallest you could be, or the very youngest you could be, is 18, but you could also be older. So your age could be equal to 18, but you could also be older. So your age is greater than 18 or equal to 18. We could also turn that around and do it the other way. We could say 18 is less than or equal to the age to vote. And we won't have to solve this inequality because the A is already isolated, so we'll go ahead and move on to the next one. All right, at Costco, 32 cans of Coke cost a total of $8.96. What is the cost per can? So I know that's my variable because I don't know the cost per can. And we're going to actually use C. So let C represent the cost for 1 can of Coke. So if I was to think about how I would solve this, I know that I would solve this by taking my total and dividing by 32 to get my answer. But we want to think about the inverse or the opposite to write our equation here. So I know that that would be multiplication. So if I take my 32 cans of Coke and I multiply them by C, the cost that each of the cans are, that should equal my $8.96. So now let's go ahead and solve. How much does 1 can of Coke cost? Well, we want to isolate our variable. So instead of multiplication, we need to do the inverse. So divide by 32, divide by 32. So C is going to equal, let's go ahead and solve that. So remember, this is like our ice cream cone. So $8.96 needs to go inside. 32 goes outside. I'm going to immediately bring my decimal up. So 32 does not go in to 8. But 32 can go into 89. Let's try 2 times. So let's do 32 times 2. 2 times 2 is 4. 2 times 3 is 6. So that works. If I added another one, I would go over. So 2 times 32 is 64. We'll subtract. 9 minus 4 is 5. 8 minus 6 is 2. bring down your 6. All right, so how many times does 32 go into 256? Let's try 8. So 32 times 8. 8 times 2 is 16. 8 times 3 is 24, plus 1 is 25. Oh, that worked perfectly. 8 times 32 is 256. Subtract, and we will get 0. So 1 can of Coke is $28 cents. So 1 can of Coke will cost 28 cents.